Hello everyone, very warm welcome to Venkat Varma Chemistry YouTube channel. I am Venkat Varma, your chemistry host and enthusiast. In this session, I am going to explain carboxylic acid in one short revision. Carboxylic acid in one short revision. Yes, let's start our session. Carboxylic acid, methods of preparation of carboxylic acid. See, methods of preparation of carboxylic acid from alkenes. Alkenes means carbon-carbon double bond. See, I am taking carbon-carbon double bond, CH double bond CH in presence of O3, ozone, and hydrogen peroxide H2O2. It gives carboxylic acid or COOH, alkene to carboxylic acid. Again, one more example, CH double bond CH in presence of hot KMnO4 solution. Hot KMnO4 solution, it gives carboxylic acid or COOH. Look at, for example, see, if I am taking cyclohexene, it is a cyclohexene in presence of hot KMnO4 solution. Hot KMnO4 solution, what is a product? So the breaking of double bond, to form a carboxylic acid, it is a adipic acid, COOH, COOH. It is a adipic acid. This is from alkenes to carboxylic acid. Alkenes to carboxylic acid. See, next method from alkynes. From alkynes. Look at for alkynes. See, from alkynes. See, alkynes means carbon-carbon triple bond or C triple bond C, or in presence of zinc and H2O, it gives carboxylic acid or COOH. Yes, again R C triple bond C, or in presence of hot KMnO4 solution. Hot KMnO4 solution, it is also gives carboxylic acid or COOH. This is from alkynes. Have a look for acid anhydride. From acid anhydride, C R C double bond O, C double bond O, or it is a anhydride. Anhydride in presence of H2O, it gives carboxylic acid or COOH. If acetic anhydride in presence of H2O, it gives acetic acid CH3COOH. CH3COOH. Yes. See, have a look for next one from esters. Ester means RCOO or C, or C double bond O or hydrolysis. C, hydrolysis. H2O in presence of H plus, it gives carboxylic acid or COOH and ROH. Again, ester with aqueous sodium hydroxide. What is aqueous sodium hydroxide? It is a base. It is a ester. It is a base to form a salt or COONA. Salt of carboxylic acid. Salt of carboxylic acid and alcohol or OH. If the salt of carboxylic acid, acidification to form a carboxylic acid. So let's take an example. See, before that, ester hydrolysis or ester base hydrolysis. Ester base hydrolysis is called as saponification. See, saponification. Yes. Let's take example. See, it is a ethyl benzoate, COOC2H4, C2H5. Ethyl benzoate hydrolysis, it gives what? It gives benzoic acid. Benzoic acid plus ethanol, C2H5OH. C2H5OH. It is from esters. See, have a look for next method from amides. Amides are C double bond O NH2 in presence of H2O. It gives carboxylic acid or COOH. Yes, For example, CH3, C double bond O, NH2, H2O hydrolysis, it gives CH3, COOH. Yes, the next method is from halo compounds. See, halo compounds means, see, look at for halo compound R, Cl, Cl, Cl. It is a halo compound with aqueous potassium hydroxide. Aqueous potassium hydroxide. See, the Cl are replaced by OH or COH, OH and OH. Carbon having 3 OH groups. So it is unstable, it losing of water. So to form a RCOOK. It is a potassium salt. See, potassium salt acidified in presence of HCl, it gives carboxylic acid RCOOH, RCOOH plus HCl. Yes, this is from halo compound. Look at for example. For example, I am taking chloroform CHCl3 with aqueous potassium hydroxide. Aqueous potassium hydroxide. It gives what? See, formic acid HCOOH. This is from halo compounds to carboxylic acid, from amides to carboxylic acid. Amides to carboxylic acids. Let's move on. Next method. See, next is from oxidation of alcohols and aldehyde. See, oxidation of alcohols and aldehyde. See, alcohol, its formula, CrCH2OH. In presence of reagents, what is the type of reagent? Potassium permanganate in acid medium, potassium dichromate in acid medium, neutral medium and basic medium, and concentrated HNO3. It gives carboxylic acid. It gives carboxylic acid. What is a reagent? Reagent is KMNO4. See, KMNO4 in acidic medium. See, acidic medium or hot condition. Yes. Next, K2Cr2O7 means potassium dichromate in acid medium, and concentrated HNO3. Concentrated HNO3 or CrO3 plus H2SO4. It is a Jonas reagent. Jonas reagent. So all these reagents to give alcohols to carboxylic acid. Alcohols to carboxylic acid. Let's take example. See, if I am taking, see, alcohol decanol. See, look at for decanol. CH3, CH2, 8, CH2OH. It is a decanol. What decanol? 1 decanol. See, 1 decanol in presence of Jonas reagent CrO3 H plus means H2SO4. H2SO4. The alcohols is converted to carboxylic acid CH3 CH2 8 means COOH. See, this CH2OH is converted into COOH. It is a decanoic acid. See, it is a decanoic acid. Decanoic acid or 1 decanoic acid. See, have a look for one more question. See, I am taking butanol. See, have a look for butanol CH2OH. Same situation, same environment. In presence of Jonas reagent, what is a product? What is a product? To form a butanoic acid. To form a butanoic acid. Butanoic acid. So this is from oxidation of alcohols. Oxidation of alcohol. If I am taking aldehyde, see, I am taking aldehyde. See, have a look for aldehyde or C double bond OH. Aldehyde. So aldehydes also converted to carboxylic acid. Carboxylic acid. See. Have a look for next method. See. Have a look for next method. See. Hydrolysis of alkane nitrile or alkyl cyanide. Alkaline nitrile, alkaline nitrile or cyanide. See, alkyl cyanide. See, what is the formula? See, what is the condition? See, complete hydrolysis. See, complete hydrolysis. See, complete hydrolysis takes place. Complete hydrolysis takes place in presence of in presence of acid medium or acidic medium like dilute HCl. Complete hydrolysis takes place. See, in acid medium, in alkaline medium, see, in alkaline medium, in alkaline medium, partial hydrolysis, partial hydrolysis, partial hydrolysis. Yes, I am taking R C triple bond N. It is a alkyl cyanide or nitriles in presence of H2O. H2O in presence of H plus. In presence of H plus. It forms RCOH double bond NH. Yes. Here breaking of pi bond, keeping of hydrogen S and OH. So it is tautomerize. It form RCONH2, RCONH2, amide. See, amide in presence of H2O H plus, it form RCOOH and release the ammonia, gas. It is a hydrolysis of alkyl cyanides. Alkyl cyanides. Yes. Have a look for next method. See, hydrolysis of acid derivatives. See, hydrolysis of acid derivatives. First of all, what are the acid derivatives? So see, I'm taking acid derivatives. So it is a Z equal to chlorine, means acid chloride, or anhydride OCOR, yes, anhydride, or ester RCOR, and amide NH2. So it is amide, it is ester, it is anhydride, anhydride, it is acyl chloride, it is a acyl chloride. Let's take example. See, I'm taking R C double bond O Z. What is a Z? Z is a derivative, acid derivatives in presence of H plus OH minus, means hydrolysis. What happens? Simply Z is replaced by OH, RCOOH and HZ. HZ. See, it is, what is Z? Acid chloride, acyl chloride, anhydride, ester, amide. See, let's take example. See, R C double bond O Cl in presence of hydrolysis HOH, it forms R C double bond OH. Yes, let's take one more, anhydride. See, R CO2 O, it is anhydride, hydrolysis, it gives carboxylic acid or COOH, or COOH. Next, ester or COOR in presence of HOH, means H plus OH minus, H plus OH minus. It gives carboxylic acid or COOH, or COOH and ROH. Again, I am taking amide or CONH2 hydrolysis H plus OH minus, it gives carboxylic acid or COOH plus NH3. This is the hydrolysis of acid derivatives. Look at for reactivity of acid derivative. See, look at for reactivity. See, what is the reactivity? Reactivity. See, for example, RCOCl. It is acid chloride or acid chloride anhydride, or C double bond O R, and next is what? Next is the ester RCOOR. Next what? Amide RCONH2, which is more reactive. Acid chloride is a more reactive than other acid derivatives. See, have a look for question. See, PHCOCl hydrolysis What happened? See, pH, C double bond, Cl, acid chloride. Hydrolysis means H plus OH minus. When Cl is replaced by COOH. Yes, again, if the acid chloride in presence of palladium barium sulfate, it is a Rosenman reduction, means it formed PHCHO. Benzaldehyde is formed. The benzaldehyde in presence of what? Oxidation K2Cr2O7 in presence of acid medium to form a benzoic acid. A is the benzoic acid, B is a benzaldehyde. B is a benzaldehyde. See, have a look for next question. See, methane chlorination. See, look at for methane. See, methane chlorination. It forms what? Methyl chloride CH3Cl. Yes, when in presence of K plus Cn minus, it undergoes SN2 reaction to form a CH3Cn. Yes or no? Methyl cyanide. Methyl cyanide hydrolysis, it gives what? CH3COOH. Acetic acid is given. Acetic acid is given. When acetic acid decarboxylation, so decarboxylation, what is the reagent? NaOH it gives methane. See, have a look for next method. From alkyl benzene. See, look at for alkyl benzene. See, see. Alkyl benzene. Benzene with alkyl group. See, have a look for benzene. It is a benzene with alkyl group or group. So, in presence of KMnO4, potassium permanganate, in presence of KOH, or H plus, or CrO3, H plus or OH minus. So this are completely oxidized to form a benzoic acid. Or is converted into COOH. See, I am taking benzene with CH3 group. In presence of KMnO4. See, in presence of KMnO4, in presence of KOH. What is the it form? Benzene with COOK. See, potassium benzoate. See, when potassium benzoate hydrolysis, it gives benzoic acid. Let's take one more example. See, look at for example, if benzene with in presence of KMnO4 in presence of H plus, what is the product? It gives benzoic acid. Yes, see, see, aromatic carboxylic acid prepared from what? Alkyl benzene oxidation to give benzoic acid. So what is the condition to form a benzoic acid from alkyl benzene? See, in this condition, this carbon has at least one alpha hydrogen. So this is a alpha carbon with alpha hydrogen. It is the entire chain is converted into carboxylic acid. See, the entire chain is converted to carboxylic acid irrespective of group. So generally, see, I am taking one more example. See, look at for example. See, benzene. See, benzene with a C2H5. Yes, see, it is a propyl group, it is ethyl group in presence of same condition KMnO4 in presence of KOH. When heated hydrolysis, what happened? So these groups are converted into carboxylic groups. See, it form COOH and COOH. Yes, the entire carbon chain is converted to carbonyl carboxylic group irrespective of side chain. So generally primary and secondary alkyl groups, primary secondary alkyl groups are oxidized. So if tertiary is not oxidizes, tertiary is not oxidizes, this is from alkyl benzene, this is from alkyl benzene. See, have a look for next method. So from Grignard reagent, see what is Grignard reagent? Alkyl magnesium halide is a Grignard reagent. What is Grignard reagent? Alkyl magnesium halide, RMGX. See, RMGX, it is a Grignard reagent. From Grignard reagent to carboxylic acid, generally alkyl magnesium halide in presence of carbon dioxide. See, carbon dioxide or dry ice, solid carbon dioxide is the dry ice, it gives carboxylic acid or COOH. Let's take example RMGX. RMGX in presence of CO2. Look at for CO2. C double bond O. C double bond O. So to generate it is carbon ion. It is partial positive charge. When the pi bond shifted to oxygen, so carbon generate the positive charge. So this negative charge attack over on this carbon. What happened? It formed RC double bond O minus. It is a salt of carboxylic acid. It is a salt of carboxylic acid in presence of H plus to form a RCOOH. It is a carboxylic acid. Let's take example methyl magnesium bromide CH3 MgBr. It is methyl magnesium bromide in presence of CO2 and H2O. CO2 and H2O. It gives what? Look at for what? It form what? CH3COOH. Yes, I am taking phenyl magnesium bromide. Look at for next question. Phenyl magnesium bromide in presence of CO2 H2O. It forms what? PHCOOH. Let's take one more example. See, MgBr in presence of CO2 H2O. It forms what? This is the product. Yes. See. Next. Are the general methods of preparation of carboxylic acids. See, have a look for properties. I will look for properties, chemical properties of carboxylic acid. Chemical properties of carboxylic acid. See the first one, acidic strength. Acidic strength of carboxylic acid. See, look at for acidic strength of carboxylic acid. See, carboxylic acid, its formula RCOOH. It is resonance stabilized to form a carboxylate ion RCOO minus to produce H plus. So it is a RCOO minus, it is a stable form. It is a stable form. To produce H plus, it shows acidic character. Carboxylic acid shows acidic character. See, if acidic strength Ka, so what is Ka? Acid dissociation constant is increases, Ka value increases and H plus concentration increases. So and pKa value will be decreases. pKa value will be decreases. Yes. Have a look for Ka is inversely proportional to pKa. Ka is inversely proportional to pKa. So how to decide acidic strength of carboxylic acid? So how to decide acidic strength of carboxylic acid? See, look at how to decide acidic acid carboxylic. Sorry, how to decide acidic strength of carboxylic acid? See, have a look for. So acidic strength. See, acidic strength of carboxylic acid. Acidic strength of carboxylic acid is directly proportional to minus inductive effect and minus mesomeric effect, minus inductive effect and minus mesomeric effect, and inversely proportional to plus inductive effect and plus mesomeric effect. Acidic strength is decided by negative inductive effect and negative mesomeric effect. Negative inductive effect increases, acidic strength increases. Negative mesomeric effect increases, acidic strength increases. So positive inductive effect increases, acidic strength decreases. Positive mesomeric effect increases, acidic strength decreases. See, look at for carboxylic acid or COOH, carboxylic acid, in presence of sodium metal to form a RCOONA to produce what? H2 gas. If it react with carboxylic acid, react with sodium hydroxide. Look at for sodium, it react with sodium hydroxide. It forms RCOONA to produce H2O. H2O is a weak acid and carboxylic acid is a strong acid. The reaction is progress. The reaction is progress. If carboxylic acid react with sodamide NaNH2, NaNH2, it forms what? RCOO, sodium salt of carboxylate ion to produce ammonia. Ammonia is a weak acid. So it is this reaction also possible if it react with NaHCO3, sodium bicarbonate. It forms what? RCOONA, salt of carboxylate ion, and H2CO3. H2CO3 is a weak acid. It is a weak acid when it decomposes to form a CO2 and H2O. This reaction also is possible. See, if whether the reaction is possible or not, how to decide? Previous session I am explained how to decide. The left hand side reaction, if the strong acid, the right hand side reaction is a weak acid is possible, the reaction is possible. The product is weak acid, the reaction is progress or reaction is possible. Yes, have a look for next, order of acidic strength. Order of acidic strength. See, order of acidic strength. Order of acidic strength. See, H3O plus hydronium ion, H3O plus is greater than RSO3H, sulfonic acid, and formic acid HCOOH, yes, and PHCOOH, benzoic acid, and RCOOH, and nitrophenol. Nitrophenol, again what? H2CO3, carbonic acid, and phenol, PHOH, yes, and RNH3 plus, and CH3OH, and H2O, and ROH, and RHC double bond, HC triple bond CH, and CH double bond CH2, and CH3. This is the acidic strength, order of acidic strength. Order of acidic strength. See, order of acidic strength. Have a look for some examples. Look at for examples. See, look at for, compare their acidic strength of following compounds. So, orthomethyl group, ortho position has methyl group, yes. So it has meta group, it is a para. All are benzoic acid. The CH3 groups are at ortho, meta, and para. See, what is in ortho position? CH3 group is present, methyl group is present. It is repelled. It undergoes ortho effect. Obviously, it is more acidic than other. It is, see, all groups are CH3. All these groups are related to positive inductive effect. It undergo positive inductive effect and mesomeric effect. Positive mesomeric effect. So, which is more positive inductive effect? Their acidic strength is decreases. So, it is ortho effect. Ortho effect possible means so the repulsion between COOH and CH3 it is more acidic than other. So it is meta position. It undergoes only positive inductive effect. It undergoes positive inductive effect and positive mesomeric effect. So A is greater than B and greater than C. Greater than C. This is the acidic strength of above the compound. See, have a look for second one. See, here benzoic acid with NO2 group. NO2 group means electron with a drying group. Electron with a drying group. So here also CH3, sorry, COOH and NO2 repulsion. So it is undergoes ortho effect. Ortho effect. So it undergoes negative inductive effect. It undergoes negative inductive effect and negative mesomeric effect. So which is more high? Obviously A is first one is more than, so B and C is a B has. So NO2 group what? It is electron with a drying group. Electron with a drying group, what happened? Its acidic strength increases. So it present two effect, minus inductive effect minus mesomeric effect. So C is greater than B. C is greater than B. This is the order of acidic strength. Order of acidic strength. See, have a look for next one. Have a look for next one. See, look at for this example. Compare the pKa, Ka and pKa. See, it is CH3, SO3, sulfonic acid. It is benzoic acid. So our order, which is more, sulfonic acid is more than benzoic acid. Yes. So it is A is greater than B. It is what? It is what? Dissociation constant Ka is greater than B. What is pKa? A is less than B. A is less than B. Why? Ka is inversely proportional to pKa. Ka is inversely proportional to pKa. See, have a look for. So in this condition also applied ortho effect. Yes, ortho effect. See, have a look for next question. See, fluoro group, hydroxyl group, CH3NO2. So it is electron with a drying group. Yes, it is electron donating group. So it is also electron with a drying group. So, and what is the order of acidic strength? Which is more acidic? See, it is strongly electron with a drying group. So it has more than other. After that what? See, fluorine. After that what? OH group. B. After that C. It is electron donating group. It is electron donating group. So which is D is greater than A, greater than B, greater than C. It is a Ka. What is a pKa? pKa means opposite. So D is less than A, less than B, less than C. This is the order of Ka and pKa. S, C. Have a look for next method. See, reaction with PCl3, PCl5, SOCl2. Yes, phosphorus trichloride, phosphorus pentachloride, and thionyl chloride. See, carboxylic acid or COOH in presence of reagent like PCl3, PCl5, SOCl2, it gives acyl chloride or COCl. Yes, so SOCl2 method to prepare acid halide is the best method. So how to prepare? RC double bond OH, see, in presence of SOCl2, this can be write like this. See, COCl. So it form RCOCl. See, COCl or COCl. Acyl chloride. It is a purest form. And sulfur dioxide and HCl, hydrochloric acid. See, have a look for the reaction. For example, CH3COOH in presence of phosphorus trichloride. What form? Acyl chloride is formed. CH3COCl in presence of what? See, see, HPO3, see, H3PO3, see, CH3COOH in presence of phosphorus pentachloride, it is also formed CH3COCl and POCl3 plus HCl, hydrochloric acid. Okay, this is the second method. This is a second method. Have a look for next method. Anhydride formation. So anhydride, how they are formed? See, carboxylic acid RCOOH in presence of H plus or phosphorus pentoxide P2O5, it gives RC double bond O, C double bond O R. It is a anhydride. So easy to write COOH S and HO, C double bond O, C double bond O. So this can be easily write to anhydride formation. See, have a look for ester formation. See, ester formation RCOOH plus ROH, carboxylic acid to form a RCOOR ester. So how to write RCOOH? Easy way to write HOR. Yes. What happened? H2O is removed to form a ester. To form a ester or esterification. Esterification in presence of acid medium. In presence of acid medium. See. Have a look for next method. Reaction with NH3. Reaction with ammonia. See, carboxylic acid or C double bond OH in presence of ammonia NH3. So it is a acid. Ammonia is the base. It is an acid base reaction to form a RC double bond O minus NH4 plus. When it is heated, it forms amide or C double bond O NH2. It is a amide. It is a amide. Yes. See, have a look for example. If I am taking benzene with a COOH, COOH in presence of ammonia NH3 is heated to form a what? See, it forms ammonium tholate, C double bond O, O minus NH4 plus and C double bond O minus NH4. When it is heated to form a benzene with COO NH2, yes, COO NH2. When it is heated, strongly heated, say strongly heated, it forms polyamide. It forms tholimide. So look at for the structure tholimide. It is a tholimide. See, it is a tholimide. Yes, it is a ammonium tholate. It is a tholic acid. See, this is for reaction with ammonia. So how to write easy way this reaction with ammonia? See, this is a way to write. See, how to write easy way. See, if I am taking, say, benzene with COOH and COOH with NH3. Yes, very simple to losing of water H2O. Yes, H2O and H2O. It forms what? Tholimide. Look at for the structure. Yes, NH. It is a trick to write. product. Yes, see, have a look for next method. See, reduction. Reduction method. See, what is a reduction reducing agent? Lithium aluminum hydride. See, carboxylic acid RCOOH in presence of LAH, in presence of LAH in ether, it gives alcohol. It gives RCH2OH, RCH2OH alcohol. Carboxylic acid reduction to give alcohol. So instead of B2H6 also used lithium aluminum hydride and diborane. So diborane, see, it is not reduce, it is not reduce NO2 groups. Yes, halo groups cannot reduce, or ester groups are cannot reduce B2H6. Only carboxylic acid can reduce. See, I will look for example. If I am taking CH3 COOH in presence of lithium aluminum hydride in ether, it gives CH3 CH2OH, no doubt. If I am taking benzene with COOH and NO2 group. If I am taking lithium aluminum hydride in ether, it is completely reduced. Completely reduced means what is the product? It forms CH2OH. It forms NH2. Yes, when if it is used to B2H6 diborane, only carboxylic acid is reduced. It is converted into CH2OH. It is NO2 only. NO2 only. So this is a reduction method in presence of LAH and B2H6. B2H6. Yes. See. Have a look for the reaction. Next reaction, decarboxylation. What is decarboxylation? Removal of carbon dioxide from carboxylic acid. See, have a look for RCOOH. What is the reagent? Reagent is soda lime, NaOH plus CaO. It gives what? Alkane. It gives alkane. See. See how to write this product. See, RCOONA plus NaOH. Very simple. It form RH. It is a decarboxylation method, removal of carbon dioxide. See, have a look for next method. So, electrophilic aromatic substitution. Electrophilic aromatic substitution. See, what is electrophilic aromatic substitution? See, benzoic acid. See, look at for example, benzoic acid in presence of concentrated HNO3 and H2SO4. H2SO4. It form. See, look at for meta-nitrobenzoic acid, to form a meta-nitrobenzoic acid. So the aromatic carboxylic acid undergoes nitration. The carboxylic acid is a deactivating group. So it substitute at meta position. It substitute at what position? Meta position. Because of carboxylic acid group is a deactivating group. Ring deactivating group. So it attacks at meta position. Meta position. See, have a look for next example. Benzoic acid. See, benzoic acid in presence of Br2 and ferric bromide Br3. It form what? COOH and Br. This is for nitration. This is for bromation. Previous is a nitration. See, have a look for. See, aromatic carboxylic acid. See, aromatic carboxylic acid. Aromatic carboxylic acids. Carboxylic acid do not undergoes Friedel-Crafts reactions. Friedel-Crafts reaction. Why it do not undergoes Friedel-Crafts reaction? See, because the carboxy group is, see, the carboxy group is deactivating. The carboxy group is a deactivating group. So the catalyst of AlCl3, the catalyst of AlCl3 bonded to carboxylic group. So AlCl3 complex formation. So due to aromatic carboxylic acid do not undergoes Friedel-Crafts reactions. Yes. So benzoic acid do not gives Friedel-Crafts reaction. See, have a look for next reaction. See, HVZ reaction. What is HVZ reaction? So Helmholtz-Zaleski reaction. So it need what? Alpha hydrogen. C R C H H COOH. It is the alpha position has alpha hydrogen in presence of red phosphorus with X2 with chlorine or bromine. H2O. What happened? The alpha hydrogens are replaced by halogen. CrCHXCOOH. It is alpha halocarboxylic acid. It is alpha halocarboxylic acid. It is a HVZ reaction. Helmholtz-Zaleski reaction. See, have a look for example. Very simple. The alpha hydrogens are replaced by halogen atom in presence of red phosphorus and halogen H2O. It is a HVZ reaction. See, it is very simple. XX. So it can see HX X is attached in alpha hydrogen position. It forms alpha halocarboxylic acid. See, let's take an example. CH3. See, look at for example. CHHCOOH. Yes, in presence of red phosphorus with X2 H2O. What happened? Very simple. It is X2. So HX. The alpha hydrogen is replaced by halogen atom to form a alpha halocarboxylic acid. See, the alpha halocarboxylic acid in presence of alkalic KOH. It form elimination is process. See, it forms CH2 double bond COOH. When it is treated with lithium aluminum hydride. Reduction with the lithium aluminum hydride. What happened? COH are reduced to form a CH2OH. It is CH2OH. S alcohol is formed when, for example, it is A, it is B, it is C. When it is treated with PCC, oxidation, pyridinium chlorochromate. What is the product? It form aldehyde. Yes, alcohol to aldehyde. It is a aldehyde. It is a acraldehyde. Yes, it is a acraldehyde. Have a look for question. C. Benzene with Br with a NO2 group in magnesium dry ether. What is the product? C. To form a magnesium bromide. See, look at for structure. See, it form magnesium bromide and NO2 in presence of solid CO2. Dry ice. It is a dry ice. It happened. What happened? It is formed. See, benzene with a C. It form OMG Br with a NO2. In hydrolysis It what happened to form a, see, look at for, it form COOH, yes, and NO2, 3-nitrobenzoic acid, 3-nitrobenzoic acid. Have a look for next question. See, have a look for next question. See, methanol in presence of rhodium metal or cobalt metal, it forms what? Methanol, alcohol, to form a CH3COOH. Carboxylic acid in presence of calcium hydroxide, to form a calcium acetate, CH3COO2. Ca. When it is heated, what happened? Acetone is formed, CH3, C double bond O, CH3. Reduction. Reduction means it form alcohol, CH3, CH2, OH. Alcohol is formed. Alcohol in presence of PBr3, it forms what? CH3, CH2, Br. In presence of KCN, it undergoes SN2 reaction. It forms CH3, CH2, CN. When hydrolysis, what happened? It forms CH3, CH2, COOH. In presence of sodium hydroxide, to form a CH3, CH2, COO, in presence of decarboxylation, it forms what? Alkane is formed, CH3, CH3. Yes, alkane is formed. When it is chlorination, it forms CH3, CH2, Cl. When silver hydroxide, to form a CH3, CH2OH. When oxidized, it forms what? E. That is a acetic acid. Acetic acid. This is for very short revision of carboxylic acid. See, I hope like this video. Don't forget to share your friends. Don't forget to give like. If you find content is valuable, make sure to subscribe our channel to insightful lecture. Thanks for watching.